Okay, this is the last video I'm making with kind of homework problems that you guys had questions about. I'm not going to write the problem out because it's in the book and it'll take too long to write it all out on the whiteboard. But if you have your book, open it to number 24 on page 662. It's a homework problem you worked on. And I've already kind of sketched a rough idea right here. If you read the problem, it says, a fishing boat leaves a marina and follows a course of south 62 degrees west. So, we start at the origin. In terms of bearing, we say south. So I go south first, then 62 degrees west. So starting from the vertical, go 62 degrees west. I go in that direction, and it says I go there 6 knots for 20 minutes. So if you do 6 knots for 20 minutes is a third of an hour, you go 2 miles in that direction. Then you're told the boat changes to a new course of south 30 degrees west. So you do the same thing. Draw another axis right here. You go south and then 30 degrees west. So this angle right here, I know it's smaller because of this picture. That's a 30-degree angle, and I go in that direction. I'm told I go that direction at 4 knots for 1.5 hours. So your distance, 4 times 1.5 is 6. This is not entirely drawn to scale. This should be smaller or this should be bigger. But it gives us a rough idea, which is all we care about. And then the problem says, how far is the boat from the marina? What course should the boat follow for its return trip to the marina? How far is it from the marina is just this side right here. And how do we go about finding it? We know this side of the triangle, we know this side, we don't know that side. Keep in mind when you look at this picture and when you draw it, this 62-degree angle is not in the triangle. The triangle, this pink line actually cuts through the 62-degree angle, which means I don't even know the measure of this angle right here. It's just something less than 62. But, and here is where all of these problems are different, and you need to be able to essentially mess around with the picture and use the geometry that you know for parallel lines and transversals and all that. This angle right here, if I kind of draw quickly a sketch of the triangle, I can break this angle up like I did, like this. This right here is 30 degrees. I was told that. That's my bearing. This angle is clearly a 90-degree angle. This angle right here, well, if you look, disregard the pink part, and if you look right here, this angle right here has to be the same as this angle right there, because they're parallel lines. So, if this is 62, then this angle is 62 right here. And if that's 62, it means that this part, the part from the horizontal, is 90 minus 62, which is 28. Now, I can find the measure of this angle right here. 90 plus 30 is 120, 120 plus 28 is 148, which means this angle right here, the whole angle in my triangle, is 148 degrees. Now, I can apply the law of cosines. Let's see, I have this side and this side, I want this side, and I have the angle opposite it. Yeah, law of cosines. D squared equals 6 squared plus 2 squared minus 2 times 6 times 2 times cosine of 148. Do all the math out. D squared equals 36 plus 4, which is 40, minus 2 times 6 is 12 times 2, that's 24 cosine 148. Throw it all into your calculator, and let's see. You get 40 minus 24 cosine 148, 60.35. So d squared equals 60.35. And then to find d, just square root it. So we do second, enter, 7.76. And there we go. Now I have my distance. Does it make sense in the context of the problem? Well, yeah. I went 2 miles this way, 6 miles this way, 7.7 miles away from the dock. That number makes sense in the context of the problem. Okay. Now it says to find my bearing back to the dock. And as far as it goes, keep in mind bearings are from north to south. So my bearing back to the dock, yep, would actually be this angle right here. And the question is, well, how do I actually find that? Well, here again, I'm going to draw a separate picture so as not to make that messy. I have the green vertical line right there that I just drew. I have the purple vertical line right here. I have the pink line, which is my bearing. That's going from here to here. The angle I care about is this angle right here, which is this angle. How do I find that? Well, these are parallel lines, that's a transversal, which means this angle is the same as this angle, which on this picture is this angle. So if I can find that, I get this over here. Now the question is, how do I get that? Well, I know this whole angle is 62 degrees. If I can find the measure of that angle in the triangle, then I can take the whole 62 degrees, subtract off this part, and get that part. So then let's see. Can I find that angle of the triangle? Well, yeah, because on the triangle that I have a triangle. Again, just a quick sketch. I'm looking for this angle. This side is 7.76. This angle is 148 degrees. That's a 2 and that's a 6. Well, yeah, I have this angle and this side. I have this side. I need that angle. Law of sines. So I get sine of 148 over 7.76 equals sine theta all over 6. Cross multiply and solve it out, we get 6 sine 148 equals sine theta times 7.76, which I'll then divide. Now, throw all that into your calculator. You get 6 sine of 148 divided by 7.76, and it's 0.409. So we get sine theta equals 0.409. But that is not my answer. I'm looking for the angle theta, so we do sine inverse. And we get 24 degrees. So theta is, we'll just round it to 24 degrees. Which tells me, here again, keep everything straight. This angle in the triangle is 24 degrees. That is not the answer to the problem. The problem asks for my bearing. And we said my bearing here is the same as this angle. But if the whole angle is 62, the part in the triangle is 24, well, to get my bearing, this part, just subtract them. 38 degrees, if my quick math is correct. I rounded those answers. I think the book actually carries them to tenths or hundredths. But again, all of these problems are different. How you solve them is different. Which parallel lines you use, which transversal you use, whether you add or subtract, it varies by the problem, so I can't necessarily go through all of them. It's just up to you to be able to look at it and say, okay, here I have parallel lines. I know transversal here, so I can get this angle, which gets me this angle. Oh, now I have a different set of parallel lines with a different transversal. I'm looking for this angle. I can get this angle is the same as this angle. And I can get this angle using my law of sines, which then gets me this angle. So they're multi-step problems. Draw it out. I can't stress enough. Draw a picture so you know what you're doing. Try to draw it reasonably accurately so that when you get an answer, your answer will make sense in the context of the problem. And here, my actual answer when you write it out, remember we have to write it as a bearing, north 38 degrees east. And again, if you think about it, my boat essentially went southwest and then southwest. So how do I get back to where I started? I go northeast. It's logical, it makes sense. That is it as far as the videos for all these homework problems that I'm going over. I will upload them. Hopefully, I don't know how long they'll take to upload, but by the end of the day, they should definitely be up. And there is also a study guide for you guys in the weekly assignments. It's not in the written assignments, it's in the weekly assignments that has more practice problems for you guys to do.